Hello, are you listening me?
Yes, sir.
Okay, let's wait 5 to 10 minutes. People are joining. Then we will start discussing.
Okay, sir.
Okay. Hello, guys. Hello.
Hello, sir.
Let's start or wait to 5 to 10 minutes because people are joining. Can we introduce? Hello.
Okay, sir.
Please tell me your name. Who are you?
Sir, Siddesh Jadhav from Mumbai.
Mumbai. Okay. So first week is over, na? Class.
Yes, sir. Almost. Yes, sir.
Okay. Then other guys, please introduce. Rajiv.
Hello, good evening. Rajiv Gyani from Raipur.
Okay.
Good evening, sir. Darshan Jethwa from Bhuj, Gujarat.
Okay. Gujarat, Mumbai, Raipur, and others. Darshan.
Yes, sir. Yes, sir.
Please introduce.
Sir, myself Darshan Jethwa. I am from Gujarat, Bhuj, and currently I am working at GIPCL
Okay.
in renewable energy project.
Good.
So, due to this project, I am interested for the photovoltaics, solar photovoltaics. So I joined this course.
Okay. Very good. Other. Shayad. Hello. My voice is clear. Hello.
Yes, sir. Your voice is clear.
Okay. Maybe internet problem, I think, in between. Wait 2 to 3 minutes because people are joining. Then let us start. Please introduce one by one. Who else?
I'm Sazia from Hyderabad.
Hyderabad. Okay. What are you doing right now? PhD or
I'm a
something?
civil engineer.
Oh,
Yeah, I work for Aga Khan Agency for Habitat as a project engineer.
okay, very good. And others?
Yeah, I am Ashish Nandwana from
Yeah.
Gurgaon.
Gurgaon, Delhi.
Yeah,
And what are you doing
I am
right now?
working as a project manager for the consultancy company.
Very good. All people are like looks like a company. Can we start?
Yes, sir.
Okay.
Yes, sir, sure.
So I am a TA on course solar photovoltaic, and course instructor is Professor Ashish Garg, and my detail is following there. Name is Harishankar Suman, and PMRF scholar at IIT Roorkee under the supervision of Professor KL Yadav at IIT Roorkee and Professor Ashish Garg at IIT Kanpur. I am joint supervision. So my email is harishankar_@iitphd.iitr.ac.in. You can me email if you have any doubts, ask any question regarding course. I am also in touch with Professor Ashish Garg because I am right now at IIT Kanpur. So if you have any doubt, so you can email me. So there is a first assignment, week first. I am discussing here 10 question based on first, and you can write also in chat if you have any question query. Clear? So let's discuss. First question based on solar irradiation. Irradiance and irradiation, what is this? So sir, discuss in lecture what is the solar irradiation. Irradiance, there is 4 option. First option is solar irradiance received by the earth. Second option is solar radiation directly incident on the earth surface. Third option is solar radiation received by the earth surface after scattering. Fourth option is intensity with which the solar radiation enter the earth atmosphere. So please answer the question. You can write in chat box. Okay, D option, Darshan. What about other? G. Please write the answer. D. Okay, D. So we know the right answer is D. Okay, very good. There is an explanation. Solar radiation is the power per unit area. What is power? Power basically any quantity with respect to per second, like that a number of photon incident within per second is known as power. So power per unit area, particular unit surface. Let's so this is the surface power density received from the sun from the electromagnetic radiation in wavelength range of the measuring instrument. So watt per meter square is the SI unit of radiance, and solar radiation is often integrated over a given time period in order to report the radiant energy emitted into the surrounding environment, joule per square per meter during that time period. This integration solar radiance is called solar radiation. So basically is the integration or known as solar irradiation or solar exposure or solar insolation. So solar radiation on Earth's surface additionally depend on the tilt of the measuring surface, height of the sun above the horizon, and atmospheric condition. Here we can see in the picture. So incoming solar radiation, reflect, absorb, or so many phenomena are happening there. So solar radiation is basically quantity which we can define how our solar power plants, there is explanation. The study and the measurement of the solar radiation have several important applications, including the prediction of the energy generation from the solar power plant, heating, cooling, load building, climate modeling or weather forecast, precipitation, dynamic radiant or cooling application, and space travel. So there is a definition of solar radiance. You can also read from Wikipedia or other source about more regarding solar radiation. Are these quiz assignment or randomly pick up question? No, this is a previous year assignment question. Okay, so like that question, which there are question from previous year assignment. Next question is based on air mass
Can we
coefficient.
get recording of this?
Yes, recording also. I will upload in.
And another thing, sir, we have 3 days. The first session was on the 3rd, and today we have another session. So, is it mandatory to attend all the 3 sessions?
Because question may be different, so if you like to join, or you can skip if you don't have time.
If there is
If
an
you-
option of
if
the
you want-
recording or
There is a recording, and you can see in YouTube. There is a YouTube link. I will provide my YouTube link. Okay. Let me share before my YouTube link first. And second question based on air mass coefficient. So question is, what is the meaning of AM in terms of the solar spectrum? Please answer the question.
It's air mass coefficient.
Yeah, okay. B, you can write in chat box. B. here is my link in chat box, YouTube channel link. I will upload the record session here. So let's discuss. Okay, D option. Second question, what is AM0 defined at? Please answer the question. Please write in chat box. Third question answer. Be on the earth surface and others. Please write. Answer C, B, C. Please all participants write the answer. A. And fourth question, choose the correct order of the sum of intensities. Please answer. Also fourth question. Then I will discuss 2, 3, 4. D. So air mass coefficient, you know, AM is air mass coefficient. First is the definition, nothing else. Air mass coefficient. Right answer is B. So air mass coefficient defined at the directly optical path length through the earth atmosphere, expressed as a ratio relative to the path length vertically upward, that is at the zenith. In exam, if you have a question like that, what is the air mass coefficient definition, please write like that. Are you able to see letters?
Yes,
Yes, sir.
you can see it.
Okay. The air mass coefficient can be used to help to characterize the solar spectrum after solar radiation has traveled through the atmosphere. So what is use of air mass coefficient? We can use in help of characterization of solar spectrum after solar radiation has traveled through the atmosphere. The air mass coefficient is commonly used to characterize the performance of solar cell. This is important line. Under the standard condition, and it is often referred to using the syntax AM following by the number AM 1.5 is almost universal when characterized terrestrial power generation panel. So use also is important to characterize the universal 1.AM 1.5 for solar cell. So AM 0 defined at we can see AM 1. On the earth surface where AM0 above the earth atmosphere? Yes or no? You can see in picture.
Yes.
So where answer is sea level? No. On the earth surface? No. Above the earth atmosphere? Between the earth atmosphere? No. Between means like that here or elsewhere. So option C is correct. And other question, choose the correct order of the sum of intensities. Here is a diagram regarding this question. Solar radiation spectrum. This side is spectral radiance watt per meter square per nanometer, and is a wavelength in x-axis, y-axis is spectrum radiance. Here is a intensity. We have to use other pen. This is the sunlight at top of the atmosphere or black body spectrum. Okay, so we can see black body has the highest, then after there is no black body is the highest, then after AM0, then AM like that 1.5 AM, some absorption spectra also there. So which option is correct now? Please write the answer of the fourth question. Now please write. C. What else?
C.
Okay. Other people? C option is correct because black body has the highest sum of intensity. If we sum or integrate over the wavelength from air to air, so we get highest. Then we know that AM0 defined above the earth atmosphere, so there is no absorption, or at 1.8 where defined earth surface. Here we can see what angle, 48.2 degree. So obvious AM0 is higher in comparison to AM 1.5. Yes or no?
Yes, correct.
Okay, so this is a like that a question, easiest question. Sir, I have one question. Okay, please. Oh, radiation spectrum we have already told. Okay, we have to go. Radiation spectrum. Radiation spectrum, this is a definition from Wikipedia. What is irradiation? Irradiance is the power per unit area. Per unit area. Per unit area, like that I have a like that area, D area where sunlight is incident. What is the intensity of the light? How we can define power? Power nothing is number of photons per unit time. Number of photons per unit time, second of, where is in second, time in second. So power per unit area known as irradiance. SI unit is watt per meter square. Sir, I want to understand charts.
Sir, actually, I want to understand next slide chart that mentioned in next slide,
Okay,
like black body, AM0.
okay,
Yes, yes. I want to understand that, sir. Yes.
okay, okay. I have another regarding this definition. AM0, AM1, AM1.5, AM223, AM3.8. So AM0 is a definition here. The spectrum outside the Earth atmosphere approximated by the 5800 Kelvin black body is referred as to a AM0, meaning zero atmosphere, useful for the outer space applications such as a satellite. You can see. Are you able to see? Hello?
Yes, we can see it.
Okay. There is a formula for AM like that. AM equal to 1 plus S is the shadow length divided by height of the object square whole square equal to 1 by cos z. Okay, we can see in geometry here is a cos z angle defined at the zenith when the sun is at zenith. So path length taken by the light through the atmosphere, which is normal to the shortest possible path, zenith, when sun is at the zenith. A ratio is known as air mass coefficient. Okay, there is a definition, air mass coefficient. And AM1, the spectrum after traveling through the Earth atmosphere to sea level with the sun directly overhead is referred to by definition AM1. AM1 equal to 0 degree to 1.1 at 25 degree for equatorial and tropical region. Can you find what is the angle for 1.5 AM? Capital should be capital. Can you calculate? AM equal to 1.5. How we can calculate angle? There is a formula. Simply equate 1 upon cosine of z and cos theta cosine z equal to 1 upon 1.5. Take the inverse. Then you can find the angle. Like that you can also calculate AM 1.1. What is the angle for? You can also find whatever. So there is a definition: m0, m1, m1.5 represent the mid altitude spectrum at angle 48.2 degree, and m2 to 3, m2 at 60 degree and m3 70 degree is useful to high altitude and in temperature latitude. 38, close to horizon. So there is a definition. I will upload these slides on where. Okay, I will provide these slides links. So next question is based on solar radiation spectrum. Here also there is a graph. You can see first region is UV, second is visible, then infrared according to the wavelength. What is the visible range from where to where? Are you able to see this range?
Yes, we can see it.
Okay.
500 to 700.
No, 500 no. 500 here.
Sir, actually it is 0.39 to 0.75.
380 nanometer to
Yes, sir.
75 nanometer. Okay, so we have to calculate what is the energy range for the visible solar spectrum. We know the formula: energy equal to E equal to hc by lambda. Okay, h is a constant, 6.626 10 to the power minus 34 joule per second, and c is the light speed, 3 into 10 to the power 8 meter per second. Lambda is a wavelength. We have the h, we have c, and have a lambda. Put the values you can find. Please, you have a 5 minute. Solve this question. 43380 in electron volt. Please solve.
It is A.
It is A. Okay.
Yeah.
What about other? Please others answer.
It's 0.66 into 3.
Let's solve. HC.
Answer B.
Answer B is the answer. Yeah, correct. B is the answer.
Okay, first solve HC. Multiply 6.626 10 to the power minus 34 and multiply by with 3 into 10 to the power 8 meter per second, a joule per second, then divide by lambda. Let's, we have to answer in electron volt, no? So divide by electronic charge. What is this? 1 point. This is right. electronic charge? How you calculate? Hello, how you convert in electron volt?
Electron volt.
Answer, we have to answer in electron volt. Please answer. How
Yeah,
you how
we
you
have to multiply this with the joule, I think. 1.6 into 10 to the power 19 joule on electron volt.
okay, you have to uh, others. Please answer other person also. Because this question is important for your course. Such type of question may be asked in question exam. This is, let's me solve. We have this number h has 6.6, c this 3.8 meter per second square, or second, because this is a speed. Sorry. Meter per second. After calculating, we have to divide by electronic charge, then we will find in electron volt. So electronic charge, this is electronic charge. Let's put here, oh, maybe bigger, 3.8, 34, 10 to the power minus 34, and light of speed 3 into 10 to the power 8 meter per second, lambda, and electronic charge divided by E, 1.6 into 10 to the power minus 39. Then this quantity in electron volt after putting the value lambda in meter. So calculate please this quantity. What will be the answer? Multiply by 3 into, please solve, 3 into 6.626, around 19.878, and power 34 minus 10 plus 8, 26, then minus 19 powers 1.16 to the power minus 19. So lambda here I have to make one more slide. insert one more slide. Okay, so hc by lambda multiply hc by lambda divided by electronic charge 6.6 into 10 to the power minus 34 and 3 into 10 to the power 8 divided by,
So answer is D.
wait, other people, 10 to the power minus 19, because you have to learn formula 1240 divided by lambda in nanometer. You will get E in electron volt. So after solving this quantity and power also in lambda, you will get 1240 approximate, or you have to put lambda in nanometer. So you have to learn this formula 1240 divided by lambda. Let's put 380 first in nanometer. Solve. (1240) divided by 380.
3.266.
3.26. Okay, and this is the higher energy because lambda is lower, and other also energy we have other lambda kita we have a 750. This is E1, E2, 1240 divided by 750.
1.65.
1.65 around electron volt. Okay, this is also electron volt. So range is 1.65 electron volt to 3.26 electron volt. Okay, clear?
Yes, sir.
Please solve this quantity and underline in circle. Are you able to get 1240 divided by lambda in nanometer? Let me solve. What is we will get? 19.87.
Sir, it is near about 1243.
Okay, wait 7 into 10 to the power minus 26. Also divided by, we have to divide by E. Divide by E. Hmm. 19.87 divided by 1.6, 12.418 like that, into 10 to the power 1 is 26, 26 minus 1 is 7. Okay, we have a lambda in meter in divide portion. So put the lambda in nanometer. So divide by, can we
Sir, 10 to power, sir, 10 to power 2, not
where
7.
here
Yes, sir.
19 or 26, please subtract.
सर -7 और lambda का आपका जाएगा 10 to
Okay,
power plus 9.
because but here is a lambda in meter, put in a nanometer, after we will get.
Yes, sir. Yes.
If we put in lambda in nanometer, then we have to multiply or divide by 9 na, in meter. So this is put in above side and this is convert into meter. First this is in meter. (12.418) 10 to the power 7, तो 2 हो जाएगा. Okay,
Yes, sir.
lambda in
Meter.
so 10 to the power 9 minus 9 known as nanometer na, divide by also. Okay, clear? Please respond others. Are you able to?
Yes, sir.
Okay, what about other? Please speak.
Yeah, understood.
Okay, so answer is
D.
D or else.
Answer is A. I think it's A.
3 we have get 3 and 1.6 na,
Yeah, it's A
3
answer.
4 380 na, or
Yes,
1.6 580 nanometer, because simple,
Yes, yes, sir.
equal to hc by lambda, and hc is 1240 lambda put in nanometer, then we will get these answer. Comfortable like that question if you ask in exam?
Yes, sir.
Okay, which spectrum of the sun is most useful in solar cell?
Sir, C, visible.
Visible. Why?
Because the irradiance is more in the visible range.
Okay, radiant is more highly intense.
Yes, sir. Yes, sir. Highly intense radiation are available in visible range, sir. As we can see in the solar radiation spectrum, sir.
Okay, and one more another reason also.
Sir, our solar panel is made up of only for UV range, visual range.
Why? Material quality may be the answer.
Yes, sir.
What is the band gap of solar panel? Silicon, what is the band gap for silicon?
I think
For silicon 1.12.
Please, 1 point convert into the, because you have a band gap 1 point what, 1.1 or something else.
Yes, 1.1.
So convert into the wavelength. You have a formula. What will be the wavelength? You can put 1.1 1240 upon lambda, then lambda 1240 divided by 1.1 Find
1.12, sir.
12 4 divided by 1.1. What? So other quality, other factor is because our solar cell material band gap lie in this region. Oh, one more fundamental question. Let me ask. Where need more space? So we know that there is a valence band or conduction band. Any material absorb light which has energy more than or equal to the band gap. Okay, then material can absorb. If has energy less, then material don't absorb. Okay,
Sir, can you repeat that when the material absorb the light?
okay, material only when absorb if band gap higher or equal to the material band gap. Incident photon has energy. Let me write. E of photon है ना, P has higher or equal to the band gap then absorb. Okay, if photon has less, then no absorption in material. Don't. Okay, clear? Sir will discuss this concept in following lecture, maybe in second lecture. Okay.
Okay, sir.
Okay, so fundamental question like that we can ask in exam. So visible. Okay, both question are clear.
Yes, sir, clear.
Okay, can we move further?
Yes, sir, sure.
So answer is first and answer is C. Okay, altitude angle. Question is, which of the following is the angle between the sun ray and its projection on the horizontal plane? Please answer. See, two more TA there in PMRF regarding this course, and this session is already done, na? Hello.
Sir, actually, some of the students join currently,
Okay.
so they are yes, so they are backuping mug up of only 1 or 2 lectures, sir. My friends also are here. That we are
Okay.
currently join this course, sir.
Okay, you can see video, है ना? There is a video in NPTEL.
Yes, sir. We are also follow the Swayam.
Okay. So please see. Answer, please see. Okay. What about other?
C. It's C, altitude angle.
Okay, altitude angle. So first let's see what is altitude or longitude, है ना. You can see in picture, this angle is known as longitude angle and latitude is phi. For define the position of on the earth. And what is zenith angle or latitude angle? Latitude angle also known as elevation angle, है ना. So there is a zenith angle, angle between the direct sunlight and somewhere else. This is not zenith angle. And angle between the horizontal and the sun at position known as altitude or elevation angle. This is the definition, nothing else. Okay, so which answer is? Here you can see which of the following angle between the sun ray, this is sun ray, and its projection on the horizontal plane, this is horizontal plane. So answer is altitude.
Altitude angle.
Okay, answer is C. Here is some more angle, azimuth angle. This is the definition: angle made in the horizontal plane between the north-south line and the projection of the sun ray on the horizontal plane, this and this, known as azimuth angle. Clear? It's vary from minus 180 degree to plus 180 degree. The azimuthal angle is the compass direction from which the sunlight is coming. At solar noon, the sun is always directly south in the northern hemisphere and directly north in the southern hemisphere. At the equinox, the sun rises directly east and set directly west. Regarding of the latitude, thus making azimuthal angle 90 degree at the sunrise and 270 at sunset. Okay, please visit this website pvo.org if you have a doubt, and you can ask me in chat. Please learn the definition of the angles. Okay, hello guys, are you listening?
Yes, sir.
Okay, so please learn
Yeah, sir.
learn the definition. A declination angle. The declination angle of the sun is angle between the equator and the line drawn from the center of the earth to the center to the sun. Here we can see in picture, line from the earth center and center to the sun. This is known as declination angle. And summer solstice in the northern hemisphere, the declination angle delta is at a maximum as 23.45 degree and also minus 23.45 degree. Maximum variation is plus 23.45 to minus 23.45. Okay, the declination angle denoted by delta vary seasonally due to the tilt of the earth on its axis of rotation and rotation of the earth around the sun. If the earth were not tilted on the axis of the rotation, declination would always be 0. However, the earth is tilted by 23.45 degree and the declination angle varies plus or minus this amount. Only at the spring and fall equinox the declination angle equal to 0. Okay, so let's further move. The approximate value of the solar declination angle on the March 30, 2022. Here is a formula. Please, n is the number of the day of the year. So please first count the number of days from the January 1st. January 1st 1 मतलब means Jan 1st n equal to 1. Please count how many days: January, February, March. Please solve this question. You have 5 minutes. Guys, are you solving? 90.
Yeah, sir.
Okay, then put in this formula and find the answer.
Sir, your sharing screen is not shown on the display.
1 minute, wait. I am shown another concept. Please solve the question. Now you can, are you see the screen?
So 2.83 near about.
Okay. Declination angle. Here is the definition of angles, and you can see in animation mode. Are you able to see my screen?
Yes, sir.
There is a
Sir, I'm not.
Who?
Sir, Darshan here.
Maybe internet problem because others are saying.
Okay, sir.
There is a formula, so definition of angles and animation also. Elevation. You can search pv.org or pveducation.org and visualize the things. Okay, Answer? What is the answer? Number of day 89. You can see 31 days in January, February 28 and March 30. Then 1 at 9 and 3, 3, 6, 2, 8. 89 days. And then put in this formula. There are two formulas for declination angle. Nothing else. 365 plus or minus. You can see in dot. So put the values. Please find the answer. Are you able to? Hello?
Yes, sir.
3.22. You can see the
Yes, sir.
solution. 89 days and formula, put the value 89 and solve the question. Then you will get 3.22 degree. Option is plus or minus maybe. So 3.22, because we know the declination angle vary 23.45 plus to minus na. So minus also. Clear? Is there any doubt?
Yes, sir.
Okay, can we move further?
Yes, sir.
Answer is B. Okay. Hour angle. Hour angle is the definition. The hour angle converts to local solar time LST into the number of degree which the sun move across the sky. This is the definition. By definition, the hour angle is 0 at the solar noon. Since the earth rotates 15 degree per hour. How? 15 degree?
Per hour.
How? 360 total divided by 24. Because earth rotate, whole earth rotate within 24 hours. Yes or no?
Sir.
Okay, so divide,
Yes, sir.
we will get 15. Okay, per each hour day of the solar noon corresponding to the angular motion of the sun in the sky of 15 degree. In the morning the hour angle is negative and the afternoon the hour angle is positive, and there is a formula HR equal to hour angle equal to 15 degree. Nothing, this is this quantity, LST minus 12 local standard time, local solar time. And what is the question? The value of the hour angle at 2 p.m. 2 p.m. means 14 LST. Put the
14,
value,
sir.
put the value and get the answer. Please answer.
$30, sir.
30 degree. What about other?
30 degrees, sir.
Okay, simple. 15 degree.
Yes.
14 minus 12 to 30. So please learn the definition of the angles. What is hour angles, before is declination angle, and
Yes, sir.
azimuth angle, altitude, and zenith also, no? These angles are important for defining the solar spectrum. Okay, last question is, there is answer, maximum day length. The maximum day length on March 30th, 2022 in Kanpur, India, located at the latitude and longitude angle are given 26.245 northern and 80.33 respectively, will be. There is a formula for maximum day length. S max equal to 2 divided by 14 multiplied by cos inverse 10 delta and 10 phi. What is delta? What is phi? Please solve these questions. You have a 5 minutes.
Sir,
Hmm?
is it del is longitude,
Del
longitude angle?
uh, del phi or del,
Yes,
okay,
sir.
okay. Del is 3.22, which we get in previous question, and phi is also given here 26.25. so we have to calculate first delta for 30th March. Okay, then we will solve. Are you clear?
Yes,
Please
sir.
solve. Please solve.
Yes.
We have already calculated delta in previous question. Where? Here. So delta 30th March for 3.22, and
Yes.
what else? Phi. What is phi? What is phi angle?
Azimuth angle.
Which is latitude, no? Not azimuth, because we have
Yes, yes, sir. Latitude.
already seen picture. I already saw you latitude angle phi. Okay,
Yes, sir.
so first you have to learn what is the angles, then you will able to solve the questions. Clear?
Yes, sir.
So please solve this question now. Please tell me answer.
Sir,
Yeah,
is there provision of calculator in NPTEL exam?
maybe or may not be. I will ask,
Yes.
then I will tell you. Next meeting, I will tell you.
Yes. Sir, is it a last question?
Yeah,
Sir, there is a problem in assignment 2.
okay.
The question is 9, 10th, 11, 12th.
1 minute. Let me know. 9, 10, 11, 12.
11, 12.
Okay.
Yes, sir.
Uh, what is problem?
So actually, I'm not understand how to proceed this numerical problem.
Please, what is question?
So question is for ninth question is for an intrinsic semiconductor
Hmm.
with a band gap of 0.72 electron volt.
7 to electron
What
volt
is the position of EF
per
at
minute
300 Kelvin?
at 300 Kelvin. Okay.
If MH equal to 5 ME,
mh
MH star equal to 5 ME star,
mh
star equal to 5 ME, 5 times M.
Okay, so you have to find the what ef.
EF. Yes, sir.
you can
Position of EF.
you can search in Google what is the formula for the Fermi energy.
Position of EF. पूछ रहा
Okay,
sir.
okay. So you have to proceed like that. You have to first you have to find the formula. What is formula for like
Sir,
that question?
actually, I put in Google, but
Yeah, then
not getting
okay,
better result.
I will I will provide in next assignment like that question. Okay,
So, but sir, submission date is 8 February.
so guidelines for me like that, you will not solve the assignments second. Okay, I will provide a hint. You too, you can search the formula for Fermi energy on Google.
Yes.
Okay, then you can proceed. Nothing else, there is a formula you can directly get.
Yes, sir.
One formula, you have to find one formula. Okay.
Okay, sir.
Okay.
ठीक है.
Sir, it's like E is equal to pi 2h 22 ml2 and under the counts n21 plus n22 plus n23. That somehow this formula.
What? I'm not understood.
Sir, its formula is little bit big, so it's
Oh, 1 minute, wait. Please answer this question. What is the answer?
12 hours 12 minutes.
12 hours 12 minutes. Any first option? Please
Yes,
others.
sir.
Please others. Please answer. Shruti, Suraj, Darshan. Oh, only these four. Shruti, Suraj.
Yes, sir. I answered that 12 minutes, 12 hours, 12 minutes. And I also wrote one Fermi energy formula in the chat, sir.
Okay. So, are you able to solve the question or not? Fermi energy.
Sir, I just find through the YouTube, not tried on paper, sir.
Okay. Please try search formula. Nothing else. There is a formula.
Okay, sir.
Okay.
Okay, sir.
So answer. Let me answer this question. Answer is 12 hours 12 minutes. You are right.
Okay, sir.
How we can solve? Let's see. S max equal to 2 divided by 15 cos inverse 10 delta 10 phi with minus sign. For delta already we have get 3.22 for 13 March, and phi is, let there is a phi 26. Okay, put this number in this equation and solve step by step. Then we will get 12.21 hours to 12 hours 0.21 hours 0.21 hours multiplied by 60 minutes. What will we get? No, 1/6. 12 hour already there, and 0.21 hour means how many minutes?
12, sir.
12. Okay, how we calculate? 1 hour equal to 60 minutes. So 1 minute equal to how many hours, or 1 hour equal to, so you have to put like that, na?
Yes, sir.
What? Multiply by 60.
Yes, sir.
Okay, and 60. Still are people joining? So this is the
Yes, sir.
last.
If we multiply by 60, so
Hmm.
it's give 12.6. So
Okay,
we can consider as
approximate
a 12 minutes. Yes, sir.
approximate
Yes. If
12
we
minutes.
give the round figure, so it gets 12 minutes, sir.
Okay, okay. So are you able to now?
Yes, sir.
Like that
Yeah,
question,
sir.
like that question may be asked in exam.
Okay, sir.
Okay.
Okay, sir.
So learn the formulas first. What is the angles? Please learn the definition. Clearly see. If you are not understood what is del lambda phi in visualize mode, you can search pbeducation.org. There is an animation.
Okay, sir.
Okay, then you can
Okay,
visualize.
sir.
So I will share these slides also and video upload in YouTube. I already shared video link in chat box. One more time I will share. Okay.
Sir, can you provide uh, this animation link in
Okay,
the description of YouTube video?
1 minute I will share.
Yes, sir.
Please see all parameter you can find from this link about the solar cell or solar angle regarding PV
Sir, in which
photovoltaic.
link?
Second link. Are you able?
Yes, sir, yes.
Okay. And 7 9 assignment second है ना.
Yes, sir.
What is the question? Other first question already told you. Second,
Sir, second one is,
I will provide hint. Please tell.
sir, can I message you personally?
You can email me, but I will not answer because you have to solve. I will provide a hint, nothing else. Okay.
Sir, please share your email, sir.
Okay. In the first slide, you can write
Harishankar at the rate
Okay,
no
sir.
no 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 no
IITR.ac.
no no Harishankar
Or
underscore s at the
Yes,
rate
sir, yes.
okay, sir.
ph.iitr.ac.in.
Yes, sir.
Okay.
Okay, sir.
And you can also ask in chat box. There is an NPTEL site है ना.
Yes, sir. Yes, sir.
There is also a link, and there is also TA another.
Sir, I want to ask also related to my research
Okay, you can ask.
persons.
You can ask.
Yes, sir. Because, sir, till now I have joined near about 2 months.
Okay.
Yes, sir.
Oh,
Through ADF, AICT Doctoral Fellowship.
okay. You can ask. Please write me email.
Yes, sir. Yes, sir.
Okay.
Okay,
So
sir. Thank you, sir.
thank you all of you. Nice session.
Thank you, sir.
And if
Sir, can
you
we,
yeah.
sir, can we get help for the green hydrogen? If any fellow professor with you, sir, so please guide us.
Let me find. Then I will tell you.
Okay, sir. Thank
Sure,
you, sir.
sir.
Okay. Okay. Please write me email.
Thank you, sir. Thank you, sir.
Okay. Okay. Thank you.
Yes, sir. I will write the email for the green hydrogen, sir,
Okay.
because currently our company ongoing research on this, sir.
Yeah.
So we
Uh,
won't help.
IIT Delhi is Neeraj Khare. One professor is in at IIT Delhi, Neeraj Khare. Hello.
Okay, sir. I mail you, sir. I will mail you that
Okay.
if
Okay.
you answered me, sir.
Okay. Okay. Sure. Thank you.
Thank you, sir.
Okay.